So, good morning everybody. Myself Acharya Vishvendra. Today I am going to discuss a worksheet on torque. So, let's begin with things in proper perspectives. So, here is the first question that torque is a vector quantity, the first one. Next is dimension of torque. So, it is m1 L2 T minus 2. Next is SI unit of torque. It is Newton meter. Next is CGS unit of torque. It is Ryan centimeter. Next is ratio of SI and CGS unit of torque. So it is 10⁻⁷. Next is torque in vector form. It is equal to R cross F. Next is magnitude of torque. It is RF sin theta, where R is the position vector of force and theta is the angle between position vector and the force. Next is torque is maximum when theta is equal to 90 degree or pi/2 radian, and they are like this. Next is torque is minimum when theta is 0 degree or 180 degree. So position vector or force are either parallel or anti-parallel. Next is graph of torque versus theta. So it's gonna be a sine curve which is maximum at 90 degree. So it will be like this. Next is if we draw graph between magnitude of torque and force, so it is proportional to the magnitude of force, so the graph will be a straight line. Next is if we draw graph between magnitude of torque and R, it will again be a straight line. Next is if we draw graph between torque and sin theta, it will again be straight line. Next is torque can also be written as perpendicular distance from force and the force. As you can see over here, torque is RF sin theta, so this distance which is perpendicular distance on force is equal to R sin theta. So as a shortcut, magnitude of torque can be written as perpendicular distance into force. Next is it can also be written as R into perpendicular component of force. As you can see from here that this distance will be F sin theta, this force will be F sin theta. So by using this you can calculate for torque directly. Next we have a question on this. Suppose O is the origin and at point A you apply a force at an angle theta and the distance between O and A is L. Then magnitude of torque about O is FL sin theta. Next one, now we have a vector problem. Suppose force is given as F1i, F2j, F3k. R is given as R1i, R2j, R3k. Then magnitude of force is root under F1 square plus F2 square plus F3 square. Magnitude of distance is root under R1 square plus R2 square plus R3 square. Next is if we calculate R cross F.